Hello, friends. Do you know what is common in all these applications which you are seeing on the screen? You have Google Maps, you have playlists, you have your inbox, then you have your social media applications. Day in, day out, we use all these applications. How our information will go out of our computer, how networking is done, and a very popular programming concept called as recursion. So, friends, there is something common in all these applications which are part of our daily life. What is something in common? It is nothing but data structures. Friends, all these applications which you are seeing internally uses or applies various data structures. Hence, data structures is a very important concept, and every data structure has got its own real time applications in computer science and engineering. So, in this particular session, we are going to understand what are the various types of data structures and application of each and every data structure. Let's move on. So let me try to define data structure. Data structure is logical arrangement of data such that you can efficiently make use of your computing resources. Computing resources, nothing but CPU and your memory. So in order to efficiently use your computing resources, you need to arrange your data properly. So systematic and logical arrangement of data is very much important for efficient usage of computing resources. So the choice of data structure, the data structure which we have selected will impact the performance. It can be with respect to execution time, or it can be with respect to space consumed by the program, which we call it as time and space complexity. So friends, data structures are of many types. Basically, data structures are classified into linear and non-linear data structures. Arrays, linked list, they generally come under linear. Trees and graphs are non-linear data structures. Hashing and indexing are couple of applications which can be either implemented using linear or non-linear data structures. So basically the classification is linear and non-linear, and under linear we have arrays, linked list, and we have couple of other data structures under linear called as stack and queue, which are implemented using arrays or linked lists. Arrays. So friends, array is nothing but a collection of homogeneous data, collection of similar data, and arrays has got lot of real-time applications. Image processing, one of the very important and unavoidable concept for any machine learning and deep learning engineer. And under image processing, images are represented using 2D arrays or 3D arrays. So if you are a machine learning or a deep learning engineer dealing with images, then images are internally represented as arrays. So you need to have good foundation of arrays. Again, inside operating system of any OS, any operating system, CPU scheduling is one of the functionality of operating system. So CPU scheduling algorithms are again implemented using arrays. So arrays are very important. Coming to scientific computing, there are many scientific applications. It can be related to weather forecasting, seismic applications, oil and gas exploration related applications, wherein we deal with large scale numbers, big numerical calculations. Again, arrays play a very important role. We generally call it as vector processing. So in scientific computing also, arrays are very very important. And coming to financial based applications, banking applications or insurance based applications, processing of a lot of historical data, etc., are again done with the help of arrays concept. Of course, implementations of data structures like stack and queue. Stack is a data structure, queue is a data structure. Both are linear data structures. Implementation of data structures like stack and queue is also possible with arrays. So hence, arrays are very very important data structures and they come under the linear data structure category. Linked list. Linked list is another form of linear data structure which basically addresses the problems which are found in arrays. So we have a couple of problems with arrays. It can be with respect to size. We need to give the size of the array in the very beginning. It can't be dynamic. If we want to make it dynamic at runtime based on the requirement, if we want to deal with that size, then we go for linked list. And another problem with array is memory allocation is always done in contiguous locations as a single unit. At times, this may lead to inefficient or ineffective use of memory. For example, I need 30 bytes of space and I do have 30 bytes of space in the memory, but 30 bytes of space is not present at a single place. Rather, it was scattered like 10 bytes in one place, another 10 in some other place, and the last 10 bytes in some other place. If this kind of memory is available, then in arrays, I can't create an array of size 30 bytes even though 30 bytes space is available. But if I use linked list, irrespective of the memory locations, whether it is available in a single contiguous location or scattered across different locations, still I can make use of that memory and I can still create my required data structures. So linked list you can say is a improvisation of array or it addresses the problems of array. And linked list has also got lot of real time applications. For example, in our inbox we have our emails. At a time hardly any inbox will show you somewhere around 40 to 50 emails, and followed by that you have two buttons, two arrow symbols, previous and next. So when you click on next button you will be seeing the next 50 emails or the previous 50 emails. So those two previous and next buttons are actually implemented with the help of linked list. And in every media player applications, whether it is YouTube music or Spotify or any other media player, we create playlist. That playlist is internally again implemented with the help of linked list. Memory management is another important concept in OS. Again, during memory management, linked list plays a very very important role in any type of OS. So hence linked list is another very very important data structure which comes under linear data structure category. Friends, under nonlinear data structures, we have two very important data structures. We begin with tree. Tree is another important data structure. Trees are used in many real-time applications, like we have a file system in our computer, right? File system deals with logical arrangement of our files, like we have drives in our hard disk, D drive, E drive, we have drive like that. Under drives we create lot of folders, under folders we create lot of subfolders. That entire hierarchy is maintained using a tree like structure. And in databases, indexing of database records is again done with the help of trees, especially B trees and B plus trees. Not only in file systems and databases, network routing is one more important aspect. In computer networks, we do have something called as network routing algorithms, where different paths are possible to send some information from one machine to another machine. and best possible path or the shortest path will be identified, and our information will be transferred through that path. So in order to identify the available paths and in order to find the best one, there are various network routing algorithms available, and all those network routing algorithms are again implemented using trees. So you can't imagine a computer network without a tree. So tree data structure is also very important. In trees, we have again various types of trees like binary search trees, AVL trees, red black trees. So every type of tree has got its own application. Like when you're dealing with searching kind of applications, then probably you go for a BST. And if we are dealing with memory management or databases, specifically when you are dealing with balanced kind of binary trees, then if your operations involve insertions and deletion apart from searching, so if you are dealing with only searching, probably you can go for a BST. But if you are dealing with insertions and deletions as well, then probably a binary search tree is not that efficient, and AVL tree can be a good option. And another tree called as a red black tree is also available, and this will help in making our insertions and deletions operations faster. So like that, every tree has got its own application. And moving on, graphs. You cannot imagine any social media application today, right, without graph. Internally, graph data structure is used in all social media applications, whether it can be Facebook, Instagram, Twitter, or whatever it is. And all GPS based applications like Google Map, etc., they are internally uses graph to represent the different routes. Web crawlers and search engines internally uses graph. So with the help of graphs only we are able to navigate from one page to another page, and network topology inside computer network is again implemented with the help of a graph. So friends, no Google Map, no GPS based applications, then we can't even imagine all other applications which are based on Google Map. Like you can't imagine a Swiggy, Zomato, or probably any other application like Uber, etc. So all modern applications which we are using today, especially social media and GPS based applications, search engines, etc., day in day out we are dealing with many applications in which internally one or other data structure is being used, and hence it is very important for any computer science engineering graduate or any person who deals with computer science to have a strong foundations in data structures. I hope this particular session gave you a broad overview of what is a data structure and what is the importance of each data structure, especially in all these real time applications. Thank you.